Welcome to the DIY Honda Garage channel. DTC P2182 indicates that the engine coolant temperature, ECT sensor 2, is out of range, which could lead to engine performance issues. The ECT sensor measures the temperature of the engine coolant, providing essential data to the Powertrain Control Module, PCM, for optimal engine operation. This sensor is typically located near the cylinder head or on the engine block, allowing it to accurately gauge coolant temperature. Sensor readings are crucial for fuel management, emissions controls, and general engine performance. Inaccuracies can trigger DTC P2182. A thorough understanding of this code is vital for effective troubleshooting, as ignoring it could lead to unaddressed engine performance issues. The ECT sensor 2 plays a pivotal role in monitoring the engine's coolant temperature, sending this information to the PCM. This feedback is instrumental in adjusting fuel injection, ignition timing, and other critical parameters for optimal engine performance. The ECT sensor 2 is usually positioned on the engine block or near the cylinder head, where it can measure coolant temperature effectively. Its proximity to the engine allows for quick and accurate readings, which are essential for maintaining engine efficiency and preventing overheating. If the ECT sensor 2 is malfunctioning, it can send incorrect temperature data to the PCM, triggering DTC P2182 and potentially causing issues like poor fuel economy or increased emissions. There are several potential causes for DTC P2182, primarily revolving around electrical issues or malfunctions. A shorted wire in the TW2 sensor line can mislead the PCM about the actual temperature being measured, prompting this code. Additionally, an open circuit in the wiring between the ECT sensor 2 and the PCM can also lead to erratic readings that trigger the fault code. Another possibility is a faulty ECT sensor 2 itself, which may not provide accurate temperature readings, rendering it ineffective. Lastly, issues with the PCM, whether due to software glitches or hardware failures, could also create situations where the sensor readings are blindly disregarded. Understanding these causes helps direct troubleshooting efficiently. When experiencing DTC P2182, several symptoms may manifest that can indicate underlying issues with the engine's cooling system. One of the more immediate symptoms is engine overheating, as incorrect temperature readings can cause the engine not to receive adequate cooling. This can lead to significant engine damage if not addressed promptly. Additional symptoms may include poor fuel economy, particularly if the engine is running rich due to incorrect temperature data sent to the PCM. Inconsistent engine performance can also be a sign, as fuel delivery and ignition timing adjustments may be based on faulty temperature readings. Typically, the check engine light will illuminate, signaling a fault that requires attention. It is essential to monitor these symptoms carefully and act promptly to avoid severe engine damage. The first troubleshooting step for DTC P2182 involves verifying the issue by powering the vehicle to the on mode, where the various electronic systems initialize. Clearing the DTC using the HDS or Honda Diagnostic system is crucial to resetting any stored fault codes before proceeding. Following this, it's advised to wait at least 10 seconds to ensure that the system has had an adequate period to clear any cached data. Subsequently, checking the HDS for any pending or confirmed DTCs allows the technician to determine if DTC P2182 is still present, confirming the persistence of the problem. This methodical approach lays the groundwork for proper diagnosis and helps isolate whether the issue is intermittent or consistent, guiding the technician's next steps. Checking the HDS for any pending or confirmed DTCs allows the technician to determine if DTC P2182 is still present, confirming the persistence of the problem. In the second troubleshooting step, ensure the vehicle is turned off before proceeding. To conduct a thorough check of the TW2 sensor wire, it's essential to jump the SCS, or Security Command System, line using the HDS. This function temporarily disables the security system, allowing for diagnostic tests. After waiting for more than a minute, proceed to disconnect the PCM connector E, which houses vital connections for the sensor. Checking continuity between test points will help identify if a short exists in the TW2 sensor wire leading to the ECT sensor 2. This process identifies any wiring faults and enables technicians to pinpoint whether the wiring poses a risk to precise readings and overall system performance. During Step 3, continuity between test points must be checked, confirming that the wiring is intact and functions as required. The vehicle should be in off mode, and both the ECT sensor 2 2P connector and the PCM connector E must remain disconnected to avoid misleading readings. Test point 1 involves the ECT sensor female terminal number 2, and test point 2 corresponds to connector E, pin number 54. If continuity is present, it indicates that the TW2/TW2 sensor wire is functioning correctly, allowing the troubleshooting to proceed to the next step. Conversely, if continuity is absent, this reveals an open in the wiring that requires repair, further ensuring that the sensor can provide accurate readings to the PCM and prevent the triggering of DTC P2182. For Step 4, the focus shifts to checking the continuity of the SG6 wire, an integral component connecting the ECT sensor 2 to the PCM. It's crucial to ensure that the ECT sensor 2 and PCM remain disconnected during this test to guarantee consistent readings. Test point 1 will utilize the female terminal number 1 of the ECT sensor, while test point 2 will reference PCM connector E pin number 45. By verifying continuity, technicians can assess the integrity of this crucial wire. If continuity is confirmed, it indicates that the SG6 wire is functioning properly, enabling the diagnostic process to advance. However, in the absence of continuity, technicians must address any open circuit issues within the SG6 wire to prevent inaccuracies in sensor readings and the reemergence of DTC P2182. Step 5 centers on evaluating the ECT sensor 2 directly. This step involves substituting a known good ECT sensor 2 to rule out the possibility of sensor failure causing DTC P2182. After disconnecting the faulty sensor, ensure all wiring connectors are securely reconnected to maintain a proper electronic link within the system. The next action is to exit the Security Command System mode using the HDS, enabling the full functionality of the vehicle's electronic systems once more. Once the vehicle is powered back to the on position, the technician should clear any existing DTCs and then wait for a brief period to allow the system to reset. Finally, checking for pending or confirmed DTCs once again will clarify the status of the ECT sensor and the system as a whole. Upon completing the troubleshooting and repair procedures, it is critical to verify that the original issue has been resolved. The technician should recheck for DTC P2182 to confirm whether the error code still appears. If the DTC is absent, it implies that the previous repairs were successful, but exploring authorized service information related to the symptoms can help ensure no further issues persist. If the code reappears, substitution of a known good PCM should be considered as a possible next step in the diagnostic process. If replacing the PCM resolves the issue, the original unit would need to be swapped out permanently. This meticulous verification process helps ensure all necessary steps are taken, ultimately leading to a satisfactorily resolved issue. Preventive maintenance is key to ensuring that DTC P2182 and similar error codes do not recur. Regular inspection of the wiring associated with both the ECT sensor and the PCM is essential to identify any signs of wear, corrosion, or damage that could lead to faults. Ensuring that the ECT sensor 2 is functioning properly and providing accurate readings is crucial for optimal vehicle performance. Regularly clearing any DTCs and monitoring for new codes can preemptively address issues before they escalate into more significant problems. Maintaining clear communication with the vehicle's onboard diagnostic system allows for timely interventions and ensures the longevity of the vehicle's components. This proactive approach can significantly enhance overall engine performance and reliability. In summary, DTC P2182 underscores the critical importance of the engine coolant temperature sensor 2 in vehicle operation. Thorough troubleshooting is paramount to effectively diagnosing and addressing the challenges associated with this fault code. Each step in the diagnostic process is crucial for identifying not just the failure itself, but also its underlying causes. Regular maintenance of the vehicle's electronic components and proactive preventive strategies can significantly mitigate the risk of DTCs like P2182. Understanding the role of the ECT sensor and how it integrates with the overall vehicle systems can greatly enhance troubleshooting efficiency and ensure sustained engine performance. By taking these measures, technicians and vehicle owners can work together to maintain optimal engine health and prevent future occurrences of this code. Please like and subscribe to the channel. See you next time.